Hi, in this video we will see how we can use the machine learning models in Waylay. For that I will start with a resource for which I was collecting data for the past month. This is the weather data for city of Ghent, and as we can see, for instance, we can see the temperature for the past 7 days. We can add, for instance, pressure. Then let me add one more data set. Let's say humidity, and let's add one more, like for instance wind speed. Okay, now what we have selected for the past 7 days for measurements, so that's what we see here. And now I'm going to save that under the name Ghent weather. Okay, so if we now go to data queries, we will see that we have created one data query which is called Ghent weather, and here we see these 4 measurements that we have selected in the previous operation. Now what we're going to do, we're going to create a machine learning model and we search for anomalies in weather based on the pattern that has been actually selected here. For that I will open my notebook, and the first thing that I will do is that I will basically connect to that environment, and what I'm doing here is I'm listing the models, and I see for the time being, let me come here, we see that there are no machine learning models in our system. What we will do now is that we will fetch the query Ghent weather and we'll see the specification for it. What we see here is indeed the window 7 days. We see 4 measurements which are in there, and what we can then do now is to just get in our Python book data which is specified by this query, and this is what we see here. The next thing we will do is to create a train query, and for this use case I will take another 7 days from June, somewhere let's say around 7th of June, and I will use this train query, so this is basically, we can plot it here, to create a model based on this data set. So I'm taking the isolation forest for this demo. Again, here it's not, probably would be better to use Sarima or other models, but again the video here it's all about how to create a model rather about the models themselves, and I will train that model based on the measurements here, and we see that the output of this isolation forest, it's in format of arrays of numbers, and if there was a negative number here, -1, that would be anomaly. We'll take now another query specified by another sliding window of 7 days, 7 days later, and verify that our predictions and anomalies based on this. So what I'm calling here now, it's the measurement execution on this window of 7 days, and what we see in this array now, we have negative values, -1, which means that we found anomalies in this data set. If I plot it here, I will be plotting by changing -1 to 1000. Reason is that I have here a pressure which is about 1000, so meaning that I just would like to get some sense of the anomalies. So this is where anomalies have been shown in this data set. If I'm happy with that model, now that I've trained that, I can upload that, and this is what I'm going to do here. I'm going to upload that by the name weather. And this is what happened now. I have uploaded the model, and the name of the model is weather. If we go back here, we see it just showing up here. Now what we will do is to update, now what we will do is to create a template. Typically templates look like this. Let me read it aloud here. We will execute a query. We'll then feed this data set into our bring your own model, and we'll look for outlier detection. Outlier detection means that we will look at the predictions that are negative -1, and then based on this, say if there is more than one negative value, we'll then create alarm. So let me test that just before running it. So if, for instance, if I take here city of Ghent again, and if I click here test, we will see here now is that the data set which will be returned back will be these arrays of values for these 4 different parameters. So this is what we see here. And what will then happen is that we will fetch that data. The outcome of that will be in the input argument here. And what you also see is that we're using the binding to get to the meta models for this resource. The same is actually happening here. The query name is designed by the specification on the resource level itself. What does it mean? If I search into this resource again, I see that the name of the model and the query name I have actually created on the meta for this given object, and at runtime I'm fetching that before executing this particular template. What we're going to do is that we'll start the template every 15 seconds. We'll bind that to resource scanned. And what's going to happen now is that once every 15 seconds, we'll be executing the query. The name of the query is defined on the city of Ghent, which is going to be Ghent weather. This is what we have done first. We'll then feed that into the bring your own model, and then we'll go for outlier detection. That all happened as we speak now. So we've got the collected data, we fed it to the bring your own model, outlier was not detected, and because of that, basically alarm was not generated. Now, finally, if you want now to start that for city of Ghent, what we can do now is that let us create a task directly from this template. We add a task, so let's say anomaly detection. We will take machine learning model that we started before for city of Ghent, and now every 15 minutes we'll be checking for anomaly detection for city of Ghent.